Um, these are old um, cell phone batteries. I want to make very smaller power bank from this. um, I'm going to see if it is possible or not. What my goal is to get more amperage than using single cell phone battery. So can it run radios or something like that better than or for longer? Is it possible to connect them in parallel and use them for better amperage? I will see. We will see the result. I'm going to connect them in parallel, and we are going to see, I think, what's going to happen. So I will show you the result. This is the self phone batteries, and now I arrange them according to their polarity. In this direction they are the negative ones, negative terminals. In this direction they are the positive ones. So I connect together all the positive in end in one terminal, and to the negatives to end in one terminal. So I will have two terminals, so I can use them as a one, as a single battery, as a single cell phone battery. Yes. Okay, this is the battery. I showed you those batteries. Yeah. After I weld them together, I join them together like this, holding the same terminals together like this, and I wrap them with a elastic material. And now I don't change them. I am using what they have before, and I put potential variable resistor. This, I think, this can show you. This can show you the picture. Show you there is load. These are the batteries. I arrange them like this, and I'm sorry, the cats are fighting, trying to fight. This is the transformer, step down transformer over there. There, as your main system, it may be 22 volt, under 10, any as your step down transformer design. Then the lower voltage here, as I explained, it will be better if that output voltage more than 5 volt DC. It will be better. Then this is the output, this will be the output, this will be the load. There will be variable resistor here and here. The reason here is this will help as a voltage divider and safer for your batteries. It also decrease the amount of current from the transformer as you need. You can control it, and the voltage over your battery also will be controlled by adjusting your potentiometer. So this also control your load current and voltage. So this is the design. So let me see. Now I'm just rotating the potentiometer. See, yeah. So as I told you, I don't charge the batteries. They are old batteries, and I don't use this potentiometer here. I have to put here in series. This is the voltage come from the transformer or charger. Now because I don't charge it, I don't put a potentiometer in series between the transformer and the batteries. So you can do it, and if the charger is with more than 9 volt, especially 6 volt, more than 6 volt, you have to I advise you have to put a potentiometer and control it, because it may hurt your batteries, and also your transformer may glow and die out. So for both it will be, for the materials and also for the people, it will be safer to use such controlling component in between. So if you use this potentiometer, it will be safe. Here you have to cut, for example, one of the line and put the two legs of the potentiometer, which by the way, there is a three legs on potentiometer. You shouldn't connect the end legs, no, one from the end and one from the middle. It is the correct way. So now you can adjust, you can vary your resistance, so you can adjust the voltage and the current amount on across battery, so it will be safe. The reason I put this diode this one, see, this one, this is diode, rectifier diode. That's the reason. The reason is if there's something short here, it won't hurt your load. Okay, it won't hurt your load. That is it. So I hope this combination, using them, number of them or more than one, I believe will give you more power. Yeah, there will be more current, so there will be more power. Yeah, so you can design this with this will be better using them like this. You shouldn't throw them. If you can do this, and make sure you are safe when you do this, because when you do electrical experiments, you have to be sure for your safety. Yeah. By the way, most of the time when I charge see this single phone battery and try to run a motor like this, it doesn't stay more than, most of the time it doesn't stay more than 20 minutes or half an hour, most of them, the used one. So now because you combine them and you use potentiometer, I think you will have multiple duration. That's what I'm expecting and that's why I believe and I hope, because logically it's like that. Because of the potentiometer you will have controlled current and multiple current supply, so it will be longer than using single battery. So I hope this will be the cheapest way to find not that much big power bank, but a smaller power bank. I'm not saying in physical or geometrically, I'm saying in form of amperage. Yeah, so it looks like this. So just see the design, the diagram. This is what I've done, and if it's important for you, you can use it. So you can use here radio, motor, you name it, for any your project which does not need that much power. The smaller power, if you need smaller power, or if you have to go somewhere with no electricity, I think you can upgrade. I use these 6 of them. You may use more, so you can upgrade. You can use them for more amperage purposes. Yeah, more powerful purposes. Yeah, thank you very much. Thank. Now it's um, an hour still spinning, even without charging. There are leftover charge in them. I don't charge them. They are, as I told you, old thrown batteries, foam batteries, and they are with not like those bigger amperage. They are smaller amperage, but as I told you, I connected them in parallel, and even without uh, charging them, they can spin this motor for more than an hour. On if you use single of one of them fully charged, they can't spin this for even half an hour. You know, you can imagine if I charge them fully, if I charge them fully, they can do more than this. So I believe this power bank is working. I think this is a proof. So it's good, I think. So you can use it for your own purposes. Yeah. Yes. Thank you very much.